Hi, my name's Greg. I'm a medical health scientist at the School of Health Science, and we're going to have a look at what's actually going on each time you turn on your iPod, plug in the earpiece and listen to your music, or equally listen to your favourite DVD and hear those sounds coming out of the movie that you're watching. What's actually happening? So if we consider sound, it's moving through the air as sound waves, and we need to capture those waves. And so the first obvious part of our hearing is our external ear. Now the external ear is really set up like a disc that can capture sound. So if you look at other animals that rely on sound, you'll notice that their ears are quite twitchy and they can turn around quite a bit. We're not quite so lucky. We end up moving our head if we want to focus up sound. But we've certainly got a pretty decent disc to capture those sound waves. So sound waves progress in to the area, we capture them with our external ear, which is obvious, and then we're under the process of what happens next. We've captured the sound wave. The sound wave will travel from the external ear into the middle ear, and you can see it's a very defined tube, and so those sound waves have been reduced down and they're now traveling through a very small tube, the middle ear. And the job of that tube is to deliver the sound waves to the eardrum, and so the eardrum is sitting as a boundary of the middle ear. Once sound waves hit the eardrum, it's literally a drum membrane that will start to vibrate. So those sound waves that have been captured will be turned into vibration waves at the level of the eardrum. Now that's quite handy because we've moved sound waves from one form to really a mechanical form. So we're moving inside the ear now with a drum that's flexing back and forth. Why does the drum need to flex back and forth? Well, the drum flexes back and forth because there's three of your smallest bones located here, the incus, malleus and stapes, and those three bones articulate with each other or bend when the eardrum is vibrating. So very small movements of the eardrum move those three very small bones. Now interestingly enough, those bones are joined by synovial joints. So just like your elbow or your knee moves very easily, those three bones will flex really easily. So a very small sound will be captured, moved to the eardrum, and those bones will be just articulating with each other very sensitively. But why do they need to articulate? They need to move the mechanical energy now from the sound and take it through to the inner ear. Now the inner ear has a double function, and we can see it here. It's made up of the cochlea, which we'll talk about in more detail, but interestingly enough we also find the semicircular canals in this area, and the semicircular canals are involved with your balance. So you can see there's three of them, and they're helping you to orientate your head in the right direction, which is also quite useful for picking up and capturing sound. But if we focus on the cochlea is a very small shell-like shape, and as your incus, malleus and stapes, very small bones, vibrate and move, they push that energy through to the cochlea, and the cochlea is attached to a nerve. Now interestingly enough, the nerve, which is one of your cranial nerves, goes directly back to your brain, and that's now moving what was originally sound waves through to electrical pathways which your brain can now make sense of. So if I put the inner ear back in, we can have a look at a couple of examples. Say you go to a loud concert and you listen to loud music, or you put your iPod on really loud. You want to make sure that you protect that eardrum. So you can see there's a small skeletal muscle here, and what we know about skeletal muscles is they contract. So if we can see where this skeletal muscle is contracting, interestingly enough, it's talking to the drum or the membrane. So when loud noises come through, we have a contraction of the skeletal muscle that tightens the drum or tightens the membrane. So it essentially protects your ear. So take the concert example, you listen to loud music, you go back outside, this skeletal muscle is now still contracting, so it hasn't relaxed, and so normal sounds you find very difficult to pick up on, okay, because the drum is not flexing like it should be. As this skeletal muscle relaxes, the drum begins to flex, and so about an hour later, you'll start to pick up normal sounds again. And so if we just take our stepwise process through, we've got a situation where we can listen to our iPod by picking up external sound waves, moving them through to the eardrum, converting them to electrical signals in the inner ear, and moving that across to the brain to make sense of those sounds.